All right, so here let's talk a little bit about your environment setup. Now I want to just let you know that when you're just getting started, or if the expectation from a new job is just a query stuff, the environment will already be set up for you. Generally the environment setup and tuning and all these things are DBAs or database administrators take care of this. But the whole point over here is, if it is really very simple and if you'd like to follow certain exercises with me, let us take some time and set up a very simple environment in order to get started. All right, so we will be using SQL Server, and again you can really use any flavor, 2008, 2012, 2014, any version. The things that we will be using are something like just creating databases, tables, joins and stuff. So pretty much whatever you choose, it should work. If you are able to install other database engines like Oracle or MySQL and stuff, feel free to do that. There will be slight syntax changes and stuff. So we'll be just using SQL Server here. And also we will be using the free editions of SQL Server so that you don't have to do any investments when you get started. So before we take a deep dive into the installation part, let's look at at least two simple differences between database and tools, right? When you install a database engine, which is typically called as a database engine like SQL Server and stuff, you put in data in it and you write queries to retrieve the data from it. That's the basic principle, right? Now, how do you pass on the query to the database engine and get the answers back? Well, there are many ways to do that. You could simply type in your syntax in Notepad or something, and then via command line just supply that query to the database engine and get it back to us. Now, this is where tools help us. Tools are nothing but just a software which helps you interact with the database. The tools are not the database. All it does is takes your query, passes it on to the database, gets the answers back, and then displays it in a human readable format. So it's for convenience sake that we use these tools. So let's look at a few differences. So let's assume you have a database. It's situated in London. There is another database in USA and another database in Australia. So as I mentioned before, you could very well connect to these databases and then just pass on your queries via text, via command line and stuff, right? But a simpler way is to use a tool. And Microsoft, when you install the database engine, it gives you an option of installing a tool called as SQL Server Management Studio, right? So in Management Studio, you can just provide a connection string, basically the address of the London database or the address of the USA database. We will look at a few examples, and just connect to that database and directly interact with the database right from the tool, right? And that's where these things become really handy. It just speeds up your overall querying effort. It provides you a lot of hints. It provides you a lot of syntax checking, right? When you type in a query, even before it sends it to the database, it can tell you whether your query is right or not. Whereas if you use your command prompt and stuff, the typical way of doing it is you type in a query, it sends to the database, and the database executes it and realizes there is an error and sends back an error message. So all those things becomes really very easy when you use a tool. And in this case, we will be using something called as a SQL Server Management Studio. We'll go through the installation, we'll connect to a few databases, and we will write some simple queries against these databases. Now, these tools are also called as IDEs, or integrated development environments. So just a technical term, nothing to worry too much about it. Just thought I'll throw it in there. All right, so we talked about databases and tools. So let me just walk you through how to install your basic tools and databases and get your environment set up and running. So let me just Google the Express link so that you can follow along with me. And I generally just type in something like this, so that the links always change, so I just hate putting it in the descriptions of videos and stuff. So I just follow the normal route of searching for it and downloading the required tools. So if you click on the first link, it'll show you a download option for downloading the Microsoft SQL Server 2014 Express. Now Express editions are free editions with very limited features, but will have everything that we will need for this course. So as soon as you click on download, it's going to give you a bunch of options over here. And what you want to do is actually go ahead and download this one, depending upon if you have a 32-bit machine or a 64-bit machine. You need to download the Express Advanced Edition. That'll basically have the database engine as well as the management studio, the tools that we talked about. So I'm just in the process of downloading this. So you can see I'm going to pause this video right now, and after it downloads, I'm going to take you through a step-by-step process of installing the database engine and the tools, and then after that we can get started with our course. Okay, so we have downloaded the software now, and you can see that it's about 1.1 GB. So I'm going to go ahead and just run this executable, and that'll give you a couple of options to install your database as well as install the tools. So let's just wait for a minute. All right, so you get two options here. I'm going to start the standalone installation, and okay, it looks like there is something running, so let me just make sure I've closed everything. Okay, let me retry it. Okay, so this will basically open up a wizard for you, and it's kind of a step-by-step process, but it's extremely simple. Okay, in the next step you see that there are a couple of options that you need to choose, and one of them is the management tools. And so your management tools get installed over here, and this is the database engine services. So we don't have to change anything, just click next. All right, and then I'm going to call this as SQL Express just to keep it very simple. Click next, and then it's going to ask you a couple of questions for server configuration. Again, we can just keep everything as it is. No need to make any changes as such. Just keep on clicking next. Okay, so don't worry about mixed mode and Windows authentication. We'll cover that later, but mixed mode is basically you just enter any password that you can remember, and this password will be used for logging into your databases. So I generally like mixed mode in my development environments. Again, nothing very special about it in this course. Just type in some password you can remember and click next. And reporting services, again, we're not going to cover reporting services, so it really doesn't matter if you whatever you choose, and then click next. And then this will take about a couple of minutes, maybe 20 minutes or 25 minutes, in depending upon what kind of machine you're using. So I'm going to pause this video for some time, and when it completes, we will just review its installation. Okay, so when the installation is completed, you will find a success page where it will show you all the components that was installed, and whether the installation succeeded or not. And let's see, what do we have here? So in SQL 2014, you should find Management Studio. So if you click on that, this was the tool I was talking about. And this is where basically you can connect to your server, right? In this case, it must have installed with a name that is the same as your machine name, or you could just type localhost or basically just a dot, and it'll connect you to the database engine. Now here, if you remember, we had basically named this instance as SQL Express, right? So we need to, so the way it works is you enter in the name, then a backslash, and then your instance name. So basically you can have multiple instances of SQL installed on your machine, and you can access them using their instance names. The other one where we talked about mixed mode was, you remember the password that I asked you to enter, that will be easy for you to remember, and that's how you log in over here. So you just enter the same password. So I had entered as pass@123, and then the login is SA. And if you enter in the password, you will basically see that you are connected to the database. So this tool is the IDE that we talked about, and this helps you connect to your database. Now in the coming tutorials, we will look at how to create a database, how to put in a few tables, how to put in a couple of data, and then how to query it. All right, so in the last few videos, we saw what is a database. It's nothing but a collection of data, a store that stores your data. How do we organize the data that is in tables, which we call it as structured information. And then basically we discussed how to get the data out of a database, that is by supplying simple queries. We went through some simple installation, we installed our database engine, and we installed our tool to interact with our database engine, and that's called SQL Server Management Studio. So in this session, what we're going to do is we're going to run through some very simple syntax, right? We're going to see what are the inbuilt things provided in SQL Server Management Studio and how can we achieve them using queries. So let me give you a walkthrough of this tool. So when you open up this tool, you basically connect to a database. Now, if you remember in a couple of slides before, we said that this tool can connect to a database in London, a database in USA, a database in Australia, and so on and so forth. And here what we have done is we have connected to a database that's installed on our same machine. So if you want to basically connect to some other database, all you do is connect to database engine and type in that server name, right? And we won't go into too much detail of that, but we're going to just play around with our local database. So once you connect to the database, you get a couple of options here. You can see what all databases are present. Like there are only some system databases that get pre-installed when you install your database engine. You do not have any user created databases here. We don't have to worry too much about securities and stuff like that, server objects, link servers and stuff. So this is basically how, where we'll get started. So we can interact with this database by supplying some queries. So the way we do it is if you click on new query, it will kind of open up a small window where you can actually type your query, and those query will be run against this database engine. And to verify that the queries that you run are fired for this database engine only, you can see in the bottom right hand corner it lists local/SQL Express. This is an area which it shows that whatever you type in over here will be issued against this particular server. Okay, now let's do one thing. Let's go ahead and create a database. All right, so I am going to create a database now. The syntax for creating a database is create followed by the word database, and then you give a database name. In this case, I'm calling my test database. Generally, multiple statements, when you have a couple of statements and you want certain statements to be committed to the database, you can use the keyword called go. Now don't pay too much attention right now on what is committing a statement, committing data and stuff like that. So this is the general syntax, and you see that whatever is the inbuilt keywords is colored in blue. Now these are the advantages when you use an inbuilt tool. So just imagine when you are writing this query via a command line or a notepad and issuing these statements to a database, you won't get these kind of support. And this is where an integrated development environment or a tool that can interact with your database can really help you. So to execute this statement, I can go to the execute prompt, the execute button, or press F5. So as soon as the command executes, you see that it gives you a result saying command completed successfully. Now if I refresh my databases, I will see that my test database has been created. Now if we expand this, you will find that there are folders for tables, views, stored procedures, and stuff like that. Everything will be empty now. You won't find any tables and stuff like that because you haven't created any. Now you don't really have to enter a query every time, and there are certain things that the tool allows you to do through a wizard. And the way you can create a database is right click and say new database, and then you can just say my test db2, and as soon as you click OK, you'll find the database being created. Now what it basically did is it gave you a wizard, you typed in your name, and under the hood it generated a query and issued that query against this database. So it's kind of just a helping layer for you to make things easy. All right, so once this is done, I am going to create a table. The way you create a table is you use the word create, that is the keyword, and instead of database you say table, and you just give any table name. I'm calling it as my test table. And then you give what columns do you need. So let's say I need a roll number column, and the data type should be an integer. A data type is nothing but you say that this column, what value should it have, and we are saying that it should just have integer values. Next, let's say you need a column for storing the first names, and you need to store characters, and the max characters, let's say, is 50, so use varchar of 50. Next, let's say you need to store last name, and again the varchar is 50. So we have just used some simple data types. You remember we talked about in the other slide where we discussed what all things can a database store. We discussed it can store text, it can store integers, it can store photographs in the form of binary, XML, and so on and so forth. This is an example where you see that we are using integer columns and variable character columns. Now if I run this query, the way you can run this query is you can basically highlight what you want to run and run this query. Now, if I execute this query, it shows command successfully completed successfully. However, if you expand my test db, you will find that it doesn't have that table. The reason being, this command is being executed to the master database, right? So if you go to master, you will find this table being created here. But that's not what we want. So you need to change the overall context of where this query needs to be executed. There are two ways of doing it. One is you go to this drop down and change it to my test db, or you just use the word use followed by the name of the database where you want this query to be fired against. So my test db. By the way, did you see that it gives you two options here? So these are the things again that those, the advantages of using tools. So I'm going to highlight this entire thing and I'm going to run it. Now there are two things that happen. One, you see this change to my test db because you're now saying use the context of my test db. Now if you expand and refresh the tables, you will find my test table. Okay. All right, so we saw how to create a database. We saw how to create a table inside a database. Let's take one step further and retrieve some data out of the database. The way you do it is select, use the word select, and then you give a list of all columns that you want to retrieve the data from. In this case, it's roll number, first name, and last name. And then you say from which table do you need this? I need it from my test table, right? And again, in this case, I need not use the word use my test db because my context is already using my test db. but it won't hurt to use that. So let me do that. If I run this, I will get blank results. The reason being, we created a table, we created a database and all those things, but we never inputted any data in the table. So let's go ahead and do that. Okay, the general syntax. Okay, before I go to inputting data to a table, I wanted to show you some of the inbuilt GUI based stuff that you can play around with. To create a table, again, if you don't want to write a query, you can right click and say table, and it'll kind of give you a wizard. So you can say this is my column 1, the data type should be integers, or you can choose from a list over here. Let's say column 2 should be something else. And then when you just save this, saving is nothing but just Control S, it'll actually save it as a table. Okay, so this is how it's saved. Now to run the query, we use the word select column names and from the table name. If you right click and say select top 1000 rows, it basically generates that query for you. So a lot of things you can actually just doing by clicking, but we want to make sure that we're comfortable writing some basic queries, because we're going to keep adding more and more information to this and take it to some amount of advanced querying levels. All right, let's go ahead and issue an insert statement. An insert is nothing but a SQL statement that will allow you to put some data into your table. So the way you do it is you use the word insert into, and then you say your table name. In this case, it's my test table. You supply the column names, roll number, first name, and last name, and then you use the word values. Again, this is a inbuilt keyword values. Whatever is in blue is inbuilt keywords. And let's say my roll number is 1, my name is Rakesh, and my last name is Gopal, right? Insert into whatever is my table name, then followed by my column names and my values. Now this should match 1 to 1, in the sense your roll number should be 1, first name should be Rakesh, last name should be Gopal. So the placement should exactly match. Now if we run this particular command, it'll say 1 row affected, right? Now let's go ahead and see if we can select any rows. Again, I'm highlighting that, pressing F5, and now you see that the database has 1 row with the data that we just inserted. So this is a good start, right? You created a database, you created a table inside the database, you put some data into the database, into the table, and now you're retrieving it. We'll go into more advanced concepts of how to retrieve data, how to retrieve complex data, how to delete a table, how to delete data, and so on and so forth. All right, so in the last few slides, in the last 20 minutes or so, we looked at how to create a database. We discussed what is a database, what all data can go into a database, how do you organize the data in the form of tables. We also looked at some basic installation about your, for your work environment. And we also looked at some very simple queries, like, how to query the data from a particular table, how to create a table, how to create a database, how to insert some data, and so on and so forth. Going forward, what we'll do is we will actually take a deep dive into querying. We'll look at various syntax, right? We'll look at aggregation, how to query a single table, how to conditionally query a single table, how to join multiple tables, and so on and so forth. We'll start with, again, very simple stuff. We'll keep on adding information, and I will be taking a little bit different approach from here onwards. What we'll do is, instead of me going through a syntax and then showing you, let's take a good database, like which has certain number of tables and data, and let's just discuss some problem statement, something like, give me all the employees who were hired after so and so date, and let's see how can we create a query for them. So it will kind of give you a real world aspect of when questions are asked, how do you go about approaching those kind of problems. So what we'll do is Microsoft provides some sample databases. We're going to go ahead and install that. The reason being, we don't have to create data. That's pretty much, you know, a good list of tables, good list of data. It's something related, you know, something like a real world data. They call it the AdventureWorks database. It's actually a very simple installation. You know, we just download it and then just attach the databases into our database engine, and then we can start querying it. I'll precisely show you how to do that. It's a very simple procedure. And then we'll look at certain things like querying a single table, then we'll look at some conditional querying, and then we'll look at some where clauses and so on and so forth. So let's go ahead. All right, so what I'm going to do is, again, I'm going to just Google AdventureWorks, and let's see. Okay, so here are some product samples. It is provided by msftdbprod.samples.codeplex.com. Let's go ahead and see what all it provides. Okay, let's go ahead and download this, and let's see. So we are using a 2014 version, so 2012 should be compatible. Let's go ahead and save this, and I already have this saved, but let's see, let's just call this as _1, and then let's save this. It's a small file. It's about 36 MB, I believe. Let's see, yeah, around 36 MB, and so let's download that. And in parallel, I'll also open my management studio. Okay, and let me connect to my database, and again you'll find the two databases that we created in our previous session. Now this has downloaded, so I'm going to go ahead and just unzip this here, and once I unzip this, you should find two tables. The MDF file is your actual database file. LDF file is where it stores logs. So don't worry too much about it right now, and we will just go ahead and use this. Let me just go ahead and put this into a different folder. And all right, so I am going to use this path, and let me go ahead and right click on databases and say attach. Once I click on attach, it's going to ask me my MDF file location, and I'm going to just input my MDF file location. Okay, so let's say okay, and it'll also pick up the LDF file, and let's click OK, and then you should see your database restored here. If you open up the tables, you will find a lot of data that they provide you. So let's select the top 1000 rows, and you see that there is some inbuilt data to play with. Now this actually gives us some base work to play with data, and we'll precisely use the same database. And if you want to follow along with me, go ahead and download this database and attach it to your local environment, and then you can follow the queries along with me. Welcome back. So in this session, what we'll be doing is we will be taking a different approach. We will be discussing some problem statements, and we'll try to write some query against it. So what we'll do is we will cover some concepts by directly writing queries against our AdventureWorks database. So let's get started. I'm going to click on new query, and let's just make sure we are using the right database. All right, okay, let's get started. Now let's look at some tables first, right? Let's look at the department table and write a select query. So select name, or let's say select star from human resources department. So star generally means that give me everything, all the columns. So if you look at our columns, we have 4 columns. Star will just give you everything. Just highlight that, press F5, and you can look at some sample data over here. So it has about 16 rows, and let's write some queries against them. So let's start with something simple. Let's say show me all the department names. By the way, you see the 2 dash I have put over here, that basically says that this is a comment, right? I mean, these statements will not be executed, and these are just plain comments where you put it in front of your code so that you can understand your code a little bit more better. And this can be any text. So let's proceed. Select name from human resources department, and let's see what it gives us. So it should give us only the names. All right, let's proceed. How about we get all the groups? Show me all the groups. So groups is basically stored in this group name. So basically what we are going to do is select group name from human resources department. So you get the idea by now, right? You use the word select followed by the column names, and then you specify the table name in order to get the results. And again, just to reiterate, the ones you see in blue are the inbuilt keywords. All right, now I wanted to introduce you to a keyword called distinct. Now if you look at the group names, you see a lot of repetitions, right? It just gives you all the rows. But what if I asked you, just give me the distinct values from here, don't repeat it, right? So something like this, show me all the distinct group names. And this is where the keyword distinct comes handy. So you say select distinct group name from human resources department. You see that it gives you just a unique set of values. Cool. Now I want to introduce you to filtering. This is where we use the where clause. So let's actually look at all the data once more, and by the way, you can selectively just highlight what you want in the query and then click or press F5 to execute that part of the query. So this is our overall data, and let's say if we just want to look at any record that has the word manufacturing in it. So you see we have record number 7, 8, and probably that's it. So this is where our where clause comes handy. So show me all the department names who are part of manufacturing, right? So the way you do it is select, let's choose name and group name, right, from our adventureworks.humanresources.department, and where we say that where group name, we introduce the keyword called like. Like is basically you say that the group name should match the word manufacturing. Now this is more likely we call it as an exact match. So it's going to look at the column group name and it's going to see if it has a value called manufacturing. Let's see what it gives us. So it gives us 2 rows, right? Now, okay. Now let's, since we have introduced where clauses, let's basically, play around a little bit with where clauses, right? You see that we filtered by using a text. Let's filter by using some integers as well. So let's just so that it doesn't get too boring, let's choose some of the table. So let's say give me all the employees from the employee table. We have an employee table here. So I'm going to just write a query called select star from human resources dot employee. I'm going to press F5, and this gives us about 290 rows. So you see here it's about 290 rows, and it has a bunch of information. Okay, now let's play around with a where clause. Okay, let's say give me a list of say all employees who have org level, you see the organization level, equal to 2, right? So here we are filtering based on an integer. Let's see how to write that. Select star from human resources dot employee where organization level equal to 2. So you see, for an integer we use the sign equal to, and for text we use the keyword like. Okay, let's see what this gives us. So you see that it gives us only the rows that have an organizational level equal to 2. Perfect. Now let me slightly modify this. Let me say give me a list of all employees who have org level equal to 2 or 3. You see, there are two conditions I have put here, right? Okay, let's see how we go about writing this. We say select star from human resources dot employee, these things remain the same, where organization level in 2, 3. So we introduce the keyword in here. Basically it says that you have a list and give me all the rows which match this criteria. Let's see what it gives us. So sure enough, it gives us all records which have an organization level as 2 or 3, right? Perfect. Okay, now let's take one more example of a text value just so that we get some practice. Let's say we need okay, let me just look at the data once more. Okay, okay, let's choose this row, facilities manager. So let's say give me a list of employees who have a title as facilities manager. So by now you must have figured out we write select star from human resources dot employee where job title, so should it be equal or should it be like? Now we are going to use a text match here, so we'll use the keyword like. Facilities manager. So sure enough, it just gives us one row. Now what happens if I don't match the casing? If I write something like this, facilities manager, all uppercase, what do you think will happen here? Let's find out. You see that still it gave you that one row back. This means that this is not case sensitive. You can pretty much, use any casing, and basically if the text matches, it's going to give you that record back. Okay, now one thing you find over here is you're doing something called as an exact match, meaning whatever you have given here should exactly match with the job title. Let's try something else. You see, I put 2 spaces in the end. So what it is doing is it is trying to match from the set of records the keyword facilities manager space space, and there is no record like that because it's doing an exact match. What if I told you there is a wildcard where you say that, okay, give me all the records that at least have the word manager in it. I don't really care whether it's facilities manager or any other manager. So the way you do that is using a wildcard. So let's say something like this. Give me all the employees who have a title, or let's say who have the word manager in their title, right? How about that? So we say select star from human resources with job title like manager. Now would this give us any result at all? No. Let's see. It won't, because it's basically checking for an exact match, right? But what we need is we need to get all the records that basically have that keyword wherever it is, but it should have the word manager in its job title. So we introduce something called as a wildcard. It's a %sign. This basically says that anything can be before the word manager, but nothing should be after the word manager, right? So if we execute this, you see that the % is anything that is before the word manager and there's nothing after the word manager, right? So this is how you this is how you do pattern matching. Now let's look at one more example. You see the job title production control manager, document control manager. Let's say we want to basically return all the records that have the word control, right? And anything can be before and after the word control. The way you do this is control, and after control you put a %sign, which means that anything can be before the word control and anything can be after the word control, but you need to have the word control in your job title. Let's look at this. See, this is how you, so in this case there is nothing, and that's also a perfectly valid scenario, right? And you see this is how the pattern matching happens. So this is kind of playing around with, you know, how to filter your data using text and using integers. All right, so let's go further. Now I want to introduce you to a little bit more where clauses, but we'll be trying to filter out some dates, right? We have here birth date, hire date. Let's try to play around with them. We'll have a separate session on how to manipulate dates, but here the point of the next few queries is just to see what are the possibilities to filter out dates. Okay, now let's say, let's just look at the entire data set. Okay, now let's say we want to get all employees who are born after, say, 1st of January 1980. So how do we do that? So give me all employees who are born after Jan 1 1980. How do we do that? Again, this will give us all the employees, but we need to add a filter. So we say where birth date, and this is where we introduce the greater than sign, greater than month, date, 1980. Let's see what this does. So sure enough, you see that it's kind of filtered all the data and given you all the records which match this criteria, where the birth date is greater than 1st of January 1980. Perfect. All right, how about now we play around with some date ranges, right? We say that give me all the employees who are born between 1970 and 1980. Let's see how that looks like. So give me all employees who are born between Jan 1 1970 and Jan 1 1980. So how do we go about doing that? So one of the ways is using, of course, you can say that where birth date is greater than 1st January 1970 and birth date I think I should just make this correction quickly here, is less than 1st of January 1980, right? So this will give you that range. SQL Server also provides you another inbuilt keyword to do this. So you say that select, let me just copy paste this part, and that's called as the between clause. So you say birth date between 1/1/1970 and 1/1/1980. So it's going to look between these dates and return the results to you. So you see that all are between 1970 and 1980. Okay, so I think you must have got a good understanding of some of the key concepts here. What we will do is we will look at some advanced concepts now. We'll look at some ordering clauses, how to order your data in ascending order, how to order your data in descending order, how to join tables, how to run some aggregations, and so on and so forth. Okay, so in the last few minutes we saw a couple of queries, and let's just continue and add more and more concepts. So let's take a quick revision of what we discussed so far. We looked at the select everything. So where we use a select star, it'll just give you everything from the table. Then we looked at some filtering aspects where we said that for text use the like operator. We also looked at some filtering where your filter criteria is an integer where we use the equal to. We also tried filtering based on a list of values, so where we use the in clause. Then we looked at how to filter based on certain text, right? Full match criteria kind of a thing. Then when we also looked at how to filter based on partial criteria, we used the percentage sign, an exact match versus a non-exact match. Then we played around with dates a little bit. We used a greater than, where we filtered our data based on birth date greater than 1980. We also looked at how to use ranges, and we also looked at an example where we use the between clause to specify two dates between which you want to filter. Okay, so let's proceed. Here I wanted to throw in a new concept called as calculated columns, and as the name suggests, it's nothing but you introduce a third column which is not a part of the table based on certain columns that the table already has, right? So for example, if a table has the quantity and the prices for each quantity, you could perhaps introduce a third column and call it as whatever, quantity multiplied by the price, something like that. So let's have a look at some examples. So let's select some of the tables so that again it doesn't get too boring. So let's see if we can use the product table. Let's see what it has. So select star from production.product. Let's see what it has. Again, let me just quickly enter my password. Oops, need to remember this. Okay, so here we have some good data, and we have list price. Okay, so let's look at some narrow range. Let's look at the name and the list price, so that we don't look at all the infinite number of columns that this table has. Okay, so a calculated column is nothing but something that you introduce. So you say select name, list price, and let's say you want to introduce a third column and you want to just give a $10 increase to the list price. So you say list price plus 10, and this is where a concept of alias comes into place. Alias is nothing but any name that you can give to a column, and I'll call this as, say, adjusted list price. You can call it anything. I'm just calling it adjusted list price, and from production.product. Okay, let's see how this looks like. Okay, so if you see that these two are the columns that the table provides. This is basically a column that you introduced, and what you basically did was that whatever was in list price, you just added $10 to it. Okay, so sometimes these things can be really very handy, and as and when you start writing more complex queries, you feel that these things can really help you a lot to put your logic in certain columns, your inbuilt logic or the logic that you have derived into certain columns for easier querying. Okay, now since we have started to manipulate and introduce stuff, I will introduce you to a few statements that can help you create tables, delete tables, and update tables. We looked at something very simple in our previous lesson, where we just wrote insert into something, values, blah, 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 and it created a table. Here we are going to take a slightly different approach. Okay, what I want is, so this statement which I have highlighted just displays the result, right? It's not stored anywhere. What I want is actually to store this in a separate table. So how do I do that? We introduce something called as an into clause. So the way it works is you write your logic, right? And then you say whatever is the value you insert into a table, right? You can give some table name. Let's call this as production.product_2. Now please note that this table doesn't exist right now. So what it is going to do is it's going to execute this query, and whatever are the values that are returned, it's going to put it into this table. Okay, so let's complete this. Now, first question is, when this table is created, where will it be placed, in which database? Well, it depends on what context you are running. Right now you are running under AdventureWorks 2012, so it will actually create a table under AdventureWorks 2012. So let me try executing this query. Okay, so 504 rows affected. Now if we refresh our tables, we should find a new table called product2 that has been newly created. Now let's run a select star from production.product2. Now if you see, there's a third column introduced here. This was not a part of the product table, but you wrote your query in such a way that you introduced the third column, and the total results of this table is actually pushed into this table called product_2. And this is where certain introducing such tables and calculations might become very handy. So imagine that you have a lot of complex logic, right? And you want to break it down into steps. You can keep putting this into separate tables and perform calculations. Now I can perform some calculations on this table, product2, and I can put that results into another table, right? And in this course, we might not go in too much depth about temporary tables and permanent tables, but let me just give you a very high level overview of that. What we just created is a permanent table, meaning this table is actually stored in the database. Whoever connects this database can actually view this table, right? There is a second form of table that you can create called as temporary table. Temporary table, let me show you. Let me push this result into another table. Here what I'm going to do is I'm going to write hash followed by a table name, and I'll call this as, say, temp table, temp name, something like this. This hash actually tells SQL Server that whatever table it's going to create should be a temporary table. Temporary table meaning this table is visible only for you. It's just a very a rough table for you. As soon as you end this session, meaning if you just close this window or open a new connection, this table will just vanish, right? You'll not have access to this table. So it's kind of, if you have again some complex logic where you just want to push some results to a temporary table, work with the temporary table, and then finally dispose of the table, that's where, that's one of the places where temp tables can really be useful. Let's try to run this query. So 504 rows affected. Now if I write select star from hash temp name, you will find those values, right? Now, as I said, this is a temporary table. If I open a new session, right, and run this query in this new session, it will actually say invalid object name, because in this session it cannot see your temporary variable, your temporary table that you created, right? So just you need to be a little careful when you're using these things. Okay, we looked at how to push data into a table. Let's look at how to delete data from a table. Now this is actually super simple. Let's play around with our new table that we introduced, the product underscore 2. Let's say you want to delete the row that has a name called bearing ball, right? So the way you do it is delete is an inbuilt keyword. You say delete from my table, you give the table name, and then you just filter on the rows where you want the deletion to occur. So delete from product 2 where name, like, we use the like operator right before when we were working with text, bearing ball. Now one thing to note here is it's going to do an exact match here, right? We don't have the % sign or something, so it's going to actually look for the word called bearing ball and going to delete that row completely. Let's give it a try. It says one row affected, which means there was at least one row which matched this criteria. Now if I run a select star from this table, you will not find that bearing ball row. See? Now since we didn't use a partial match, there are some rows which have at least that word called ball bearings, but it will not get deleted. But you get the idea. Okay, and finally I also wanted to tell you something about an update statement. An update statement is nothing but something that updates a given table, a given row, right? So let's run through an example. The way you write it is using the keyword update followed by your table name. So it basically says that update this table, and then you give a condition as to what should be the update and which rows should it affect. So you say set name equal to, let's say update this one, blade, right? Set name equal to blade underscore new. I'll just call it new. The updated value should be new, where name like blade blade. Okay, now please note you are assigning this new value to this column, so that's why we don't use the like operator here. What we are saying is update this table where name is blade, and whatever rows qualify that criteria, just update the name to blade underscore new. Let's see what happens now. It says one criteria match one of the rows matched your criteria, and then we say select star from production dot product 2, and we should find our updated value here. See, there you go. So this is like a high level overview of how you would insert some data, delete some data and update some data. And again, these kind of temp tables and permanent tables really help you when you have super complex logic and you just want to cut them into smaller pieces and then work with smaller tables, kind of a thing. The other criteria where I could think of is I was working with a table recently which had like millions and millions and millions of rows, and I just wanted to do some analysis on a portion of the data, right? One way is, of course, to use where clauses and stuff like that. But what I did was that I just pushed 1,000 rows from there into a temp tables and I worked with it. It's just more faster. So depending upon what things you use, you might want to use a temp table or a permanent table, and so on and so forth. So in the last few sessions, we have been seeing how to query some tables. But if you observe, we have always queried via a single table, right? We have not referenced 2 or 3 tables. We just fire our queries against a single table. Now, in real world, most likely you will have to query multiple tables together, right? Data is actually shared across multiple tables. And that's where we use the concept of joins. So joins is nothing but, it's a syntax, it's a query which helps you join 2 or more tables based on certain criteria, right? When 2 or more tables are to be joined, there will be at least one column which is common across both the tables, and we'll look at a few examples. And this is one of the most commonly occurring scenarios where we have to join 2 or more tables. So depending upon what kind of data you want to retrieve, in the sense, if you're joining table 1 and table 2, do you need just the common rows, or just the rows which are from table 1 and which is matching from table 2, and various scenarios. There are certain types of joins that are introduced. So we'll go through them one by one. We'll look at some visual examples, and then what we'll do is we will take our AdventureWorks database and actually write some queries, so you can get to see in real world how does this happen. All right, so there are 3 types. Mainly there are 3 types of joins. One is an inner join, next is an outer join, and third is a cross join. Let's look at them one by one. Okay, inner join. Let's assume you have a table which is pretty simple. Okay, you have an employee ID column, the first name and the last name. Pretty simple table. But you have a second table called as, say, which just stores the salary of employees, right? So it has an employee ID and a salary. Now, what if I asked you, give me all the employees, their first name, last name, and the salary? In the previous sessions, when we had to do something like this, we would have expected that the salary column is in the same table. But here, we are seeing it's in 2 different tables, right? So that means there should be some way in which we could join these 2 tables and get our results. Now, if you observe closely, you see that employee ID is common across both the tables. So I can say that employee 1, whose first name is Michael, would have a salary as 10,000 because the same employee ID is referenced in the second table. And that's where the concept of joins really becomes very interesting. Now, the speciality of this inner join, this type of join, is that you will only get the rows which are common across both the tables, right? In this case, there are 3 rows that are common across both the tables, and that's what will be returned. The thing is that there should be at least one match between both the tables, right? In this case, employee ID 1, 2, and 3 are perfect matches between both the tables, and you will get 3 rows when you inner join these 2 tables. Don't worry, we will look at an example where this will be more and more clear to you. Okay, let's look at outer joins. Okay, let's consider a table, right, which has employee ID, first name, and last name. Let's look at another table which again has an employee ID and the salary. This is pretty much the same scenario that we discussed in the previous slide, but here we are just taking a very slightly different approach. We are going to introduce a new concept called as outer joins. We introduce a third table which stores employee ID and phone number. Now, what is interesting in these 3 tables? In a previous slide, we saw that table 1 and 2 had the exact number of rows, right? You had employee ID 1, 2, 3, employee ID 1, 2, 3 in both the tables. Here we are introducing a third table called as whatever, phone number, right? But you see that employee ID 3 is missing here, right? Employee ID 3 doesn't have a phone number, and hence they haven't even entered in the table. Now, what if I told you give me all the employees and their phone number if they have them, right? So one of your answers would be, okay, let's join table number 1 and table number 3. But in inner join, as I mentioned before, only the common rows will be accounted for. Meaning if you inner join table 1 and table 3, you will get employee ID 1 and 2, but not 3, because there is no entry for employee ID 3 in table 3. I hope you're getting the difference. Here we are not talking about common rows, right? And that's where the concept of outer join comes into play. So let's introduce the concept of left outer joins, right? Okay, let's take a table which is very simple: employee ID, first name and last name. Let's take another table, employee ID and phone number. Pretty much the same thing that we just discussed in our previous slide. Now, what happens when I left join table 1 with table 2? Left join basically says that give me all the rows of table 1. Okay, give me all the rows of table 1 and also give me all the common rows of table 2, right? But if you don't find a common row, if you don't find a join, just replace by null. Might be confusing. Let's look at the results. So you see employee ID 1 and 2 are common across both the tables. So it perfectly joined. This is, you would have got 2 rows if you had just inner joined both these tables. But a left outer join basically says take everything from the left side table, whatever is your left side table. In this case, it is table 1. Take everything, right? Take whatever you can join from table 2, that is the right side table, and whatever you cannot join, put a null over there. So in this case, if you see employee ID 3 is not present in table 2, so it cannot join, so it simply put a null in the phone number column. If we have to imagine this a little bit visually, you say take everything from table 1 and all things that are common, right? And then whatever didn't match, replace it with a null. All rows from left table included, non-matched entries from right table will have null. Okay, so this is the main difference. Let's just take a step back. What is inner join? Inner join, just look for common rows. What is an outer join, especially a left outer join? Take everything from the left hand side table, take everything which matches with the right hand side table, and the ones that does not match, just replace it with a null. Okay, let's look at something different. Right outer join, it's exactly the opposite. So let's take another example. Table 1, 2 rows, 2 columns, employee ID and parking spots, right? Then you have table 2, which stores employee ID and employee names. Now, how would you join these two tables? Employee ID is the common column which will help us join these two tables. But if you look at the right hand side table, it has 2 extra rows for employee ID 3 and employee ID 4, right? Now, if I right outer join, what will happen? Table 1, right join table 2, meaning take everything from table 2. And whatever matches with table 1, substitute the values. Whatever does not match, put a null, right? So that's the basic difference. When you have a left outer join, that means take everything from the left table. When you have a right outer join, take everything from the right table. So that's the major difference. So all rows from right table included, non-matched entries from left table will have null. Now, if we look at this visually, you see that everything from table 2 is included plus the common rows, and whatever is left out is substituted as null. So 3 concepts. Inner join is nothing but just look at the common rows. Left outer join, nothing but take everything from the left hand table, whatever matches, get the values. Whatever does not match with the right table, substitute a null. Exactly opposite is the right outer join. Take everything from the right hand side table, whatever matches, join it. Whatever does not match with the left table, just substitute a null. Again, we will look at more and more examples, so don't worry. Okay, We looked at left outer join, we looked at right outer join. Now let's introduce another concept called as a full outer join. Now full outer join is actually pretty simple. It's basically a combination of what we studied before for left outer join and right outer join, right? So we take everything from left hand side table, whatever matches, take it from right hand side, substitute by null, and do the same thing for the right hand side table. Let us look at an example. So table 1, just 2 columns, column 1 customer ID and customer name. Table 2, 4 columns over here. I'm sorry, 3 columns but 4 rows over here. You have an order number, order name, and customer ID. So which is the common column across both the tables? It is customer ID, right? So now just imagine what will you do if table 1 left joined with table 2, meaning you'll have everything from here 1 and 3. So, and whatever does not match, it will be substituted as null, right? Now let's look at how things change when we do a full outer join. We take, first of all, we take all common rows, right? So when table 1 is full outer joined with table 2, the customer ID 1 is common. So you take the common set of information. Okay. Now customer ID 3 is not there in table 2, so you substitute by null. Okay. Now do the same thing from table 2. Let's look at customer ID 2. The information is not present in table 1, so we substitute a null. Similarly, we follow for all the rows. So basically it's a combination of your left outer join and right outer join. So you will have all rows from your left hand side table and all rows from your right hand side table. Whatever matches, you will find a complete row set. Whatever does not match will simply have nulls. Okay, so all rows from your left and right table are included. Non-matched entries from left and right table will have null. So if we were to look at this a little bit visually, this is how it will look like. You'll have everything from table 1 plus common rows plus everything from table 2. Again, we will look at some examples which will make it more and more clear. But the bottom line is it's just a combination of left outer join and right outer join. And in the end, let us introduce one more called as a cross join. Take an example. Table 1, 2 columns. Table 2, 2 columns, right? Department ID is basically the common column here. So cross join is nothing but this row, the first row, will be joined with row 1 and 2 with the second table. Similarly, second row would be joined with 1 and 2. So each row from table 1 will be joined with every row from table 2. So your end result will look something like this. So you have 1A joined with sales and marketing, right? And then 2A2 joined with sales and marketing. So every row, if you see, every row from table 1 is joined with every row with table 2. Includes rows from both the tables. So this is a very high level overview of inner joins, where we just take common rows, outer joins, which basically has multiple things. One is left outer join, where we say take everything from left hand side table and whatever does not match with the right hand side, put nulls. Similarly, right outer join is the exact opposite. Then we looked at full outer joins, and then we looked at cross joins. So don't worry, let's look at a few examples now. So in the last few sessions, we looked at joins, right? And we looked at what is an inner join, what are outer joins, what are the types of outer joins, and we looked at a few examples. So we covered these concepts more conceptually, right? We looked at a couple of tables, and then we looked at how the results would look like. What we're going to do now is actually write some queries. We're going to look at how inner joins work, how to join two tables and stuff like that. So let's actually take the same examples that we covered in our slides. And what I'll do is I'll actually create those tables, insert some values, join those tables, and so on and so forth. So some of the queries that we look at here, like something like creating a table, inserting values and stuff like that, might be more repetitive for you. So if you feel it's too boring, feel free to forward it until the point where you actually reach the joins part or the outer joins part, and so on and so forth. So let's get started. So when we looked at joins, we looked at something like this, right? We looked at two tables, and we said that when we join these two tables using a common column, what we get is the common rows between those two tables. So precisely, let's do that. Let's create two tables. One, let's call it like my employee or something, another my salary. And let's just insert 3 rows in it. And once we insert them, let's look at how an inner join output will look like. All right. So let's go ahead and create a table. And I'm going to call this table as, say, my employee. So I'll say create table my employee, and let's say it just has 3 columns in it, and I'm going to call these columns as employee ID, and that can be an integer. Then you can have a first name that can be a variable character 20, and then a last name. Simple stuff. So just 3 columns, and just want to make sure that I spell things correctly here. Okay, now let's just put all these in our AdventureWorks database, and later on, we can remove them. So I'm going to create this table. Oops, and let me make sure. So these are 2 options in SSMS wherein you can export the results to a file or a grid. We'll just export it to a grid. All right, so we have a table. Now let's go ahead and insert some rows into it. So insert into my employees. Values, and then what do we want to insert? Say 1 Michael Scott. All right, and I'm going to copy it 3 times now just to make sure we insert 3 rows, and then I'll have to make sure that I change these values. So let me do that real quickly. And all right, so we have a table and we have about 3 rows in it. Let's just have a look at that table. Oh, there's an object, and let's go ahead and insert 3 rows and say select star from my employee. All right, we have 3 tables, 3 rows and a single table. All right, so now next what we're going to do is we're going to do the same thing for my salary. And again, if you feel that these are too repetitive, go ahead and feel free to skip this part. I'm creating a table called my salary. I'm just making it consistent, and then again it's going to have an employee ID, and that can be an integer, and then it's going to have, say, salary, right? And I'm just giving it a float, so you can include decimals if you want, but that's not a point here. And again, the same thing, insert into my salary, and then the value should be for employee ID 1, I'm giving him $10,000. And then for 2 and 3, I'll give them like 8,000 and 6,000, something like that. All right, so we have a table and we have inserted 3 rows, and then let's do select star from my salary. So these are the 3 rows. All right, so pretty much we have the same table that we looked at in our example, right? And what I'm going to do is, just so that you can look at both the tables together, I'm going to paste them one below the other. So these are the 2 tables. Now, what will happen when we join both these tables via the employee ID? So it's going to give you all the common rows that both these tables have. So let's look at that. So I'll start off with select star, and again, I'm just saying we're choosing everything, but we'll go ahead and change this later. And I'm going to say from my employee, and generally we have to give an alias here. So the alias name can be anything, A, ABC, anything that you like. And now I'm going to say inner join, employee inner join with my second table. That's my salary. And again, I'm going to give alias over here. Once I inner join both these tables, I need to also tell them what is the common column between these tables. So it can be a dot employee ID equal to b dot employee ID. Simple stuff. I forgot something. It's on a dot employee ID equal to b dot employee ID. Perfect. Now I'm going to remove this char and I'm going to say that I need the first name and the last name from my first table and the salary from my second table. And incidentally, my first table is referred by the alias a. So if I do a dot first name, a dot last name, and my salary is in my second table, which has an alias as b, so I can say b dot salary. So imagine that you are joining two or more tables. You can easily refer to the various columns between these tables via this particular alias dot column name. Okay, let's execute this entire thing. You see that this is select star from my employee, this is select star from my salary, and this is how it joined. So three rows in both the tables, and the resultant is 3 rows in the last table because there were 3 common rows. So one thing to note again here is inner joins means it'll only give you the rows which are common between these two tables. All right, great. So we have some amount of knowledge in inner joins. Let's proceed and look at some outer joins. So I'm going to start with left outer join, and we're going to look at what we discussed when we mentioned about outer joins and left outer joins. When we discussed our left outer joins, we said that we have 2 tables, right? The first table is what we just created as my employee, and the second table is something that we'll create. But if you see that the first table has 3 rows and the second table has only 2 rows, what left outer join does is it takes every row from your left table and it takes all the rows from your right table that is common with your left table, and whatever is not common, it just marks as at null. So this will be the result. You see that the row number 1, 2 are common, so you find data from both the tables, whereas the third row is only available in your left table, so it could not find a corresponding match in the right table, hence it replaced by null. Let's see how it looks like when we write a query. All right, so we have our employee table. We just need to create our phone table. So I'm going to say create table my phone, and again, let's just keep it simple. Let's say employee ID as integer and phone number as integer. Okay, and then let's go ahead and insert 2 rows. Insert into my phone values can be 1 1 2 1 1 1 2 3 3 4 2, something like that, right? And then we say insert into my phone values for my second employee. All right, so we have a phone table. We have inserted 2 rows into it, and let's look at the employee and phone table one below the other and see how it looks like. All right, so we have the phone table, we have the employee table, and let's see how the syntax looks like and how the results look like when we do employee left join with phone. So the syntax is pretty much the same. Select star from my employee, and again you need to give an alias, so I'm giving it as a, and this time instead of an inner join I'm going to write left join with my phone, and I'm going to give it an alias on a dot employee ID because that's the common row equal to b dot employee ID, and instead of star I need first name, then a dot last name, and I need a dot b dot salary or phone number. Okay, so you see that we're joining the first table with the second table using a left join, and let's see what it gives us. This is your first table, this is your second table. It could match the first 2 rows, employee ID 1 and 2, employee ID 1 and 2, but it didn't find an entry in the third row for the third row, employee ID 3, so it replaced it by null. So basically what you're saying is whatever is in the left part of this clause, take every row. And if you find a match, well and good. If you don't find a match, put a null. That's the whole concept of this. So the same thing also applies for right joins. So let's just extend that same concept in right joins. So when we discussed right joins, what did we say? We said that we have two tables, and it's kind of the opposite of a left join. You see that in your table 2, you have 4 rows. In your table 1, you have 2 rows. And out of those 2 rows, both the rows are present in both tables. That is, those are the common rows, right? So when you do table 1 right join with table 2, it basically says take everything from table 2. And if you find a match with table 1, well and good. If not, put a null in the corresponding cells. So employee ID 1 and 2 common, yes, you got data from both, we're good. Employee ID 3 and 4, there is data only in the table 2, in the right table. So take that and put nulls for your left tables. So let's look at this. So we have the employee table right now, and we just need to create one more table called, say, parking, and then we can test this out. Perfect. So let's go ahead and create a parking table. So create table my parking, and then again I'm just going to create some columns here, employee ID integer, and then let's say parking spot can be varchar of 20. All right, and then what we're going to do is we're going to again insert some values. Insert into my parking. Values can be for employee ID 1, the parking spot can be A1, and for employee ID 2, the parking can be A2, right? So let's look at the employee and the phone and the parking tables side by side. Execute this, insert 2 rows, and then select star from my parking. All right, so table 1 employee, table 2 parking. What we are going to do, just for clarity, let me do it this way actually, so that you can look in the same order. Okay, so what we're going to do is select star from parking or my parking and give it an alias A, but this time we're going to say right join with my employee B on, what is a common column is A dot employee ID equal to B dot employee ID. And then I'll go ahead and say from my first table I need the parking spots, from my second table I need the first name and the last name. Let's look at how this looks like. All right, the first table, second table, we saw that the two, when you say right join, everything from your right table is accounted for. Whatever it found a match, A1, A2, it filled in those, and whatever it did not, it basically put a null over there. So it's kind of, you know, if you understand left join, it's opposite and so on and so forth. Now let's proceed. Let's look at how a full outer join looks like. So kind of when we discussed full outer join, what did we look at? We looked at a table, we looked at a customer table and an order table, and we basically said that it's actually a combination of your left join and right join. That is, whatever is common gets filled up on both tables. Then kind of you look at from a left join perspective, where you see that, you know, you account for all the rows, and then whatever matches you fill in, whatever does not match you put nulls, and do the same thing for the right table as well. So let's create these two tables so that you can have a look, right? And this is how visually it looks like. All right, so I am going to go ahead and create a customer table. So I'm going to say create table my customer, and then I'm going to say customer ID, and then what did we have? Customer name, yeah, customer name, and then I'm going to just insert 2 sample values. All right, and I'm going to copy this and insert another row. Perfect. So we have a customer table and we have 2 rows in it. Insert into each. Oh, okay. I forgot a parenthesis. Okay. All right. And then we had a order table as well. So let me just quickly go ahead and create the order table. We had the order number and I think we had the order name, and then just a customer ID, which is basically your column where you can use to join your 2 tables. All right, so we have an order table, and then what we're going to do is insert into my order values can be 1, call it sum order 1. And 1. Okay. Just 4 values, 1, 2, 3, 4. Okay, so we have 4 values now, and then what we're going to do is we're going to look at both these tables together. Oops. Okay. 2 rows in the first table, 4 rows in the next table. Okay. So how should the output look like? Let's look at it. Select star from your first table. In this case, it's a customer table. Give it an alias. And now you use the word full outer join, and then you use my order as the second table and join via a dot customer ID equal to b dot customer ID. And then I would like to look at basically everything, but let's just use your column names. I need the customer ID and the customer name from my first table. Oops. And I need a couple of columns from my second. Let's take the order number and the order name. Okay, that should be it. And let's just format this a little bit so that you can see things more clearly. Okay. So the first 2 rows were common between both the tables. So that's why you find table from both the tables. But you don't find. So actually, let me do one thing. Let me just make it a little more interesting. I'll say truncate table my customer, and I will actually use a slightly different data. Okay, now let's see how things look like. Okay. Now you see there's just one row that is common across both customer ID 1 and customer ID 1. So that's why you find the entire data from both the tables. Next it goes to the second row. 3, John, it puts in here, it didn't find anything in the right side table, it put nulls. Now, it does the same thing for your right side table. The first row it finds common, so naturally it actually matched the columns with both the tables. And then for order number 2, 7, and 8, there are no corresponding entries in your customer table, so it put nulls. So it's kind of a combination of your left join and your right join. Okay, now before we conclude, let's look at our last concept, that is cross join. Cross join, what we said is if you have 2 rows from table 1, 2 rows from table 2, cross join will actually join with every single row, right? Table 1 will join with 2 rows, 2 rows for each row of table 1. So that's why you see that the rows start repeating. Again, best way is to look at an example. So let's actually look at these 2 itself, right? So we don't waste time creating another table. So we say that select star from my customer The syntax is cross join with my salary. And let's see how this looks. Okay, so my customer, you cross join with my salary, so that's why you're seeing every entry has 3 rows, right? So 2 rows from the first table, 3 rows from the second table. So the first row, that is customer name Rakesh, customer ID 1, joined with every single row from your second table. Similarly, took the second row, joined with every single row in the second table. So that's basically what is a cross join. And another interesting way to write this is something like this: my customer, comma, my salary, and it'll pretty much give you the same result. It's just an alternate way of representing it. So we looked at some few examples of how to join stuff, and again, sometimes it can be a little confusing, and it's just writing more queries and getting more used to it. Basic rule of thumb is look at 2 tables, look at what is the common column, and basically analyze what kind of data you need. Do you need just the common rows, or just the rows from all the rows from left table, all the rows from right table, and accordingly just apply our joins. And you can extend the same concept to multiple tables as well. You can write table A inner join table B on some common column, and again you can write inner join table C with again a joining column. So once you master this concept, it actually becomes really very interesting, and for data analysis, because you'll have lots of tables, and this will allow you to easily join each table, run aggregations, run summations, and so on and so forth. So I hope you enjoyed the concept of joins. See you later. In this session, we are going to take a deep dive on date functions. So most of your data will contain some dates, right? You can have, if you're dealing with, say, products, you can have order dates, shipping dates, stuff like that. And it kind of becomes very critical when you start querying these and start applying some calculations. For example, if you want to know what is the difference of days between whatever is today's date versus some column date in a table, say, how much days have been passed since the order was shipped. Typically how you would do is get today's date, look at the column value, whatever is the date value for shipped, and you take a difference. So SQL Server allows us to do all these things using some inbuilt functions, right? If you want to get today's date, there is a function. If you want to add 2 dates, there is a function. If you want to find the difference of just days between 2 dates, there is a function. Similarly, if you want to find a difference between 2 dates and just give me the month, how much months have passed between the 2 dates, there's a function. So there are a lot of functions, and actually you can even use a combination of these lot of functions to create something very complex. So let's start with something very basic, and then what we'll do is we'll start writing some queries against some table. So the way you can do that is, say, select get date, right? And if you run a query, you basically get today's date, that is July 11th 2015, right? So this is the very simplest form of date manipulation. Get date will just give you the current date. Okay, now if you want to say subtract 2 days from this, right, you can say get date and just say -2, and it'll kind of show you it's July 9th 2015. Okay, so just basic subtraction. Many times you don't really want this entire date, right? You just want to know the date parts, the month part, or the year part, and that's very critical, right? You might find so if you get a query like, okay, give me the average, not even average, give the number of years that a person has been with the company. So what do? You look at the higher date, you look at today's date, and you subtract both of them, and then basically get the number of years. One of the ways of doing that is, okay, give me the number of days, and 1 year is 365 days, and you do the math. But SQL Server provides us some inbuilt functions to do these things. So Let's have a look. It's typically called as the date part. So it goes something like this. Select date part, and then basically you say I want the year for today. So whatever is today's date, I just want the year section of it. So this will give me 2015. And again, you can always give aliases, like we discussed before. So this column will be called as year number. And similarly, you can do something like this for months. It's called and you can refer to the MSD and documentation to get all these syntaxes. But when you start a bracket, it generally gives you a hint as to what will be returned and what is the expected parameters. So this will give you 7 since today is July, and by now you must have got an idea of how this works. So for day, what you do is you use the term DD, and today is the 11th day. Okay, so this is the date part. Now we looked at one of the ways in which we just added 2 days to this, right? But it gave you the entire string, and then you can manipulate the dates. But there are some inbuilt functions which will allow you to do this, and that's precisely called as date add. So what date add does is, it allows you to add 4 days or 5 months or 3 years, depending upon how you want to deal with it, to any date. So we can say something like select date add. Date add is a function, and as soon as you open the bracket, it kind of gives you a hint as to what interval you want, what's the increment and the expression. So let me say that I want to add 4 days, so that's why I use the day parameter, to current day. So today is July 11th. When I add 4 days, you will get July 15th, right? And again, you can use the same concept to put any custom date. This can be a column, something like that. So say July 4, 2015 should give you July 8, 2015, right? Okay, and you can extend the same concept to month. So you say add 4 months to whatever today is, so you get November, and then you can also use the same concept to add 4 years to the current date, so you get 2019. So you get the idea. It's basically just playing around with the parameters and then working this thing out. Now dates are really powerful once you know at least some of the basic functions, because most of our analysis and stuff is going to require dates, and it's really critical when we combine aggregation with dates and give me the average turnover rate or something for a quarter, right? So here so many things are involved. When you say a quarter, then definitely dates are involved, right? And then you'd find averages and stuff like that. So you might have situations where you can say, okay, for the last 3 months, give me say the number of hours worked, but don't count Saturdays and Sundays, right? So you can always use intelligent queries to find the day part, and if the day part is 6 or 7, Saturday or Sunday, then you avoid them and so on and so forth. But these things just give you a basic idea. All right, let's look at a table. So let's look at let's try to find some table which might have a date, and then at least try to run one query against it. So let's see, work order should have a date probably. Yeah, it has date, time, date, time. Wow, it has 3 dates. Cool. So let me just show you some sample data from this table so that we can play around with it. Let's call what, work order, something work order. Okay. Okay. Let's say select top 10 star from this. Okay, I need to make sure I'm connecting to the right database. Okay, so it has a work order ID, a product ID, it has a start date, end date, due date, right? Let's try to play around with this. Okay, let's say I want the work order ID. So that's pretty simple. We don't need to do any manipulation here. I need the product ID, again very simple. I need the start date and end date, And what I need is the difference between those two things. So I'm going to use the date diff function, and I'm going to say difference of days between the start date and the end date. Okay, and from this table. So I just want to show you how to utilize this when you're querying against a table. And then it gives you that it's 10 days, so it's 7/4 and 7/14, so 10 days, right? So think about it this way. The table that I showed you basically had stuff like due date, start date, and end date, and you could actually say if due date minus the difference between these two is greater than 0, then it's under schedule, or it's things like that. You can play with this infinitely once you know the different functions and how to use them. Okay, let's try to do something tricky now. Let's say I want to get the first day of this month. Okay, so the way you can do is, let's see. So this month is the 11th of July. So one of the ways that we can get the first day is, let's do one thing. Let's see. Let's get the date part of this one. So date part, day, and get date, right? So this is 11. So what I need to do is I need to get today's date, and I need to subtract it with the previous day, right? That will give me answer as 1. So what I'm going to do over here is, this is the previous day, so this should give me my previous day, hopefully, yes. And what I'm going to do is I'm going to use the date add function, and I need to subtract, so I'm using this, and say from today. So this will give me the first day of this month. So again, you see that there are so many functions involved here: date part, get date, so on and so forth. Now again, once you know these different functions, you can really play around with different combinations and get a feel of it. So these are the various things that you can do with dates. Of course, there are lots of other functions also provided, but to get started with, these are the basic things you would require in order to run some queries. In this session, we are going to have a look at some functions that SQL Server provides. So there are many types of functions that SQL Server provides that is inbuilt. One of them being aggregate functions, right? So you have a set of rows and you want to find the averages, you have to find the sum, you find the count, and so on and so forth. The second set of aggregate functions that you would commonly use is string functions, right? You have a lot of data that is just text data, and you want to manipulate that text data, right? Something like convert everything to uppercase, or convert everything to lowercase, or concatenate two strings, something like that. So those things would be really very useful when you want to do that operation. So let's look at some examples. And what we're going to do here is we are going to reuse a table that we created. You remember we created the my salary table, and we're going to run some aggregate functions in that one. Okay, so let's first look at the my salary table. So I'm going to say select star from my salary. And sure enough, we just have 3 rows. We kept it very simple. And what we're going to do is we are going to find the average of the salaries. That is average of 10,000, 8,000, and 6,000. That is this column. And the way you can do that is using an inbuilt function called select avg, or average, and you give the column name, right? And it'll automatically add them and divide by 3, and it'll give you the result, 8,000. Now similarly, if you just want to get a count, right, there is an inbuilt function called count of salary and from my salary. So it's basically 3 entries. Okay, now tell me what will happen if I write something like this: select count of star from my salary. basically saying count of everything, what will happen? You will still get 3 because it's a row wise operator and it's just counting the number of rows. Okay, all right, let's proceed and let's open up our table again and write some other function. So what we'll do is we'll find the summation of all the rows, that is 10,000 plus 8,000 plus 6,000, and the way we do it is using the function called sum of salary from my salary. Right, so let us execute both of this. So 10,000 plus 8,000 plus 6,000 is 24,000. Okay, let's look at something else. Let's find the minimum salary. So your minimum salary is 6,000 from the whole table, and so the way you do it is using the word min, the keyword min, salary from my salary. Minimum is 6,000, and similarly you can extend that same idea to find the maximum salary as well. So these are some of the functions that are inbuilt to perform some aggregations. So of course, when you query, you will use where clauses and stuff. Give me average month wise or give me average year wise. That's where your group by clauses and all those come into picture. Give me just the average of distinct rows, something like that. But you get to combine these different set of functions to kind of manipulate your data. All right, so once we have this, let's move forward. Let's look at some string functions, and for string functions what we're going to do is we're going to use the my order table that we created just in the last session. So select star from my order and just 4 rows to keep it simple. Some order 1 2 3 4. This is when we played around with joins. We created this. So let's look at a concept of concatenating 2 strings, right? And the way we do it is you can just first of all write something like this: concat my string 1 and my string 2. Oops. String 1 comma string 2. So this is how we get it. If you want to put a space just to make it look nice. So the concatenate function or concat function basically takes a set of parameters and just joins them together or concatenates them together. So if we were to concatenate strings from this table, let's try out something like this: select order number, order name, and let's say concat my order name, give it a space with itself, right? Just order name space order name. And let's also give this an alias as concatenated text from my order. Let's see if this works. Sure enough, you see that it basically concatenated the same values, and that's the result. Okay, now since I have you here, let me show you something else. Let's concatenate with a random number so that we look at one more function. It is called RAND, random function, and it'll just return a random number. I believe it's between 0 and 1, but I'm not sure. Yep. Okay. All right, so now since we are playing around with string functions, sometimes you would like to not concatenate a string but to take just a portion of your string, right? One example I can give you is in one of the databases I've been dealing with, it stores email messages, right? It has a column to store a subject line, it has a column to store some body and stuff like that. And typically this data basically says that in the subject line of the email, the first 5 characters would be some product ID followed by a colon and followed by some custom subject line. So I wanted to extract the first 5 characters from the subject line that is a string. The way we do it is, there are many ways to do it, and let me show you some of them. One is using the left function. The left function goes something like this: select, and let's say order number, order name, and what I want is the first 5 characters in the left side, right? So I want from my order name only the first 5 characters. Let's see what the results look like. So sure enough, it gave me just the 5 characters. Now similarly, you can do the same for your right also, and the function name is, just call right. Let me put a comment here so that it's easier, and it gives you from the rightmost part 5 characters. We looked at left, we looked at right. Now what if you want just something in the middle, right? How would you do that? And the way we do that is using something called as a substring. Substring is again an inbuilt function, and what you can do is select order number, order name, and we use substring. And the way this works is you give the column name and say that, okay, I need from character number 2 to character, and go 5 places to the right from character number 2. Let's look at the results. That will give you a good idea. So from my order, and you see that what it did was it started from character number 2 and went up till 5 places to the right. So if I say something like 3, it'll start from character number 3 and go to 5 places, and so on and so forth. So this is where you need to do something in the middle, right? You need to do some string manipulations right in the middle. Okay, now you see the order name column, everything is in uppercase. What if I want to just make everything as lowercase? The way we do it is using the lower function. So select order number, order name, just to look at it, and I say that use the lower function and give me just the order name in lowercase. So it just converted everything to lowercase. And naturally, you can use the same thing to convert everything to uppercase also. And the keyword is pretty much, you must have guessed it, it's called upper. And this will give you the uppercase characters. Okay, great. So we looked at uppercase, we looked at lowercase. How about we look at the length? I mean, many times you might want to know what is the length of the string. And we'll look at some examples where you would use it. But the way you can get the length is using the len or length function, which is again inbuilt. It'll just count the characters, count the number of characters in your column, in your input, and return an integer. So everything is 10 characters and it returns an integer. All right. Now let's look at, let's try to do something interesting. Let's combine a couple of functions. What I want to do is, in this order name, I want to display the first letter in uppercase and remaining everything in lowercase, right? So how do you do that? Well, there are many approaches to do that, and one of the way is, let's say order number, order name, and the way I'm going to do it is using the concat function, right? I'm going to convert the first letter to an upper and convert everything else to lower, and I'm going to concatenate both. So how can we do that? So first thing is I need to convert the first one to upper, so I'm just going to use the left function and get the order name and just take 1 character. So this will give me the the first letter in uppercase. Then what I want to do is I want to say convert. So I'm saying let's say, okay, next I want to select from character number 2 to end of string, right? So again, it's basically the substring function, and what I need to do is order name from character number 2 to end of string. Now how do I know end of string? It's very simple. We use the length function to get the length of string, right? And we just concatenate both of them. Simple. Hopefully this should work. Let's see. Oops, this didn't work. Oh wait, substring. I need to convert this to lower. Okay, this, perfect. So you see that this basically took the first character, converted into upper, then it took from second character to end of the string, that converted to lower, and we just concatenated both these strings. So this is one example where you would use your string manipulations and stuff like that. The other one I wanted to show you was the trim functions. Now many times your data may contain spaces, right? Something like this, my text, some custom text, space, 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 space. So naturally this it accounts for spaces as well, and the way you can actually see that is, if you run a length function over this, it'll actually count the spaces as well. So you see the length is 10, right? And the way you can remove these spaces is there are multiple functions, the two functions actually. One is remove spaces on the left side and remove spaces on the right side. So it's called the left side L trim or the left trim, and you just insert it's a function. So if you just write L trim and your text, it'll basically remove the spaces from the left side of the text, but it'll still retain the ones on the right side. And by now you must have guessed, to remove them from right hand side, you basically use the R trim. Now if you want to remove spaces from both, you rightly guessed it, you use both, left trim and then right trim. Okay, so these are some of the examples where you would use these functions, and I think we have covered quite some of the critical stuff that you would require: some date manipulation, some string manipulation, aggregate functions and stuff, which you would typically require in your day-to-day work or analysis that you would ever need to do. All right, so we are at the end of the course now, and let's take a quick rewind of what we have done so far, and also quickly discuss about what are the next steps, what are the other things you could do in the BI stack, and what are the other trainings that I provide. First of all, we looked at database concepts, table concepts. What is a database? How do tables fit in? How data flows into it? We also looked at basic querying, right? How to create tables, how to create databases. We looked at select queries. We looked at create, update and delete, how to join different tables, how to run some aggregations, how to manipulate dates, what are the date functions, and so on and so forth. So by now you should have you should be comfortable writing basic queries and playing around with data. So if you are maybe going for an interview which requires some simple T-SQL queries, this should pretty much, you should be able to get started with this one. Now if you want to take the next step and learning more in the BI stack, the next steps would be definitely knowing more about stored procedures. It should be custom functions, not customer functions, triggers, views, temporary tables, and so on and so forth. And I will be releasing an intermediate course as well soon that should give you a good idea of various things that you could do apart from just simple queries. And advanced concepts would be another series which would cover things like database tuning, query tuning, and so on and so forth, like what is differences between clustered indexes, non-clustered indexes, how do you tune them, how do you decide where to use a index and stuff like that. We'll also look at some CLR, C# CLR profilers, and how to load very large data sets, so on and so forth. So we'll look at a few examples in those where we actually load huge amount of data sets. The next, of course, is a different concept where we talk about ETLs. ETLs is nothing but extract, transform, and load. Is basically how to extract data from different systems, say CSV, Excel files, from an Oracle to a SQL to Oracle, or something like that. And that's where a lot of ETL concepts and stuff come into play here. Things like, when you are transferring huge data sets, what should be a buffer size, what is your speed, what is the speed of your machine, and stuff like that. So there are different things to consider over here to optimize your extract, transform, and load. And again, we'll split it up into beginners, intermediate, and advanced courses. There are a couple of things we can do in reporting, majorly being SQL Server Reporting Services, or SSRS. And that's a Microsoft product, and what are the different reporting tools is provided, reporting facilities it provides. Tableau is another tool where I'll release a separate course where we can look at what are the different aspects, how can you create really good visualization by connecting to different data sources, how to quickly create reports, how to quickly create very professional quality reports, and so on and so forth. Sometime later I will start with some big data analytics as well. We'll start with Hadoop for beginners, how to get into just basic querying, what is Hadoop and stuff like that. We go into something intermediate, and then we'll go into some advanced concepts as well. So hope you like my course. Thank you very much for watching my course, and please provide me your suggestions and feedback as well. Thank you.